How can we obtain a minimum phase version from a given filter? We basically mirror in the zeros from outside the unit circle. So take our above example of the piece of the sinc function filter. So we see the 0 at 1.93, which we need to mirror in. So we neglect the 0 at infinity, which comes from starting with a 0 sample. To achieve this, we first take the z-domain polynomial of the impulse response and cancel that 0 by dividing by the polynomial with only that 0. 1 minus 1.93 times e to the power of minus 1. Fortunately, we have the function deconvolve, which is identical to polynomial division. So to do this, we are importing SciPy signal. We are using the deconvolve function, and it will return b and r. So r is the remainder. In our case, it's practically 0, which means we can indeed divide our polynomial without any remainder, which we expect since the 0 we divide by was in the polynomial, so that we can always factor it out. After that, we can multiply the obtained polynomial b with the 0 inside the unit circle at position 1 divided by 1.93 by multiplying it with the polynomial with only that 0. So 1 minus 1 divided 1.93 times z to the power of minus 1. So here now we are using this convolve. B comes from here. And then we have here the hsinc MP is now our minimum phase version of the filter. So this is what we did. We had here the roots, and then we use the deconvolve hsinc 1 and minus rt1. So this here, it will give us the polynomial b and remainder r, and then we are multiplying, convolving the b with 1 and 1 minus 1 divided by rt1 conjugate, which is this part here, and we get our minimum phase version of our filter. So we can take a look at the impulse response. It looks like impulse response of the minimum phase filter, and observe that our filter now became non-symmetric with the main peak at the beginning of the impulse response.